Joel had $7,586 in his savings. And then his target to save $10,000 by the end of the year. How much more money will Joel need to save? This is a classic part-whole model question. What is a part-whole model? It is just one bar model, a one bar model. Okay, so this bar model represents the total. The total is what he aimed to save. That is $10,000, right? So he aimed to save $10,000. However, he only managed to save not the whole 10,000. He only has this much. So he have $7,586. I want to know how much more he need to save here. And how do we do that? How do we find how much more? That part there. The whole model is 10,000. Part of it is 7,586. I want to know this question mark part. Minus, right? To get the parts, the whole is given. To get the part of the parts, we minus. Okay? So 10,000 minus 7,586. And when you minus, you are going to get 2,414. So 𝗀𝗫 is correct. Very good. The sum of two numbers is 3,160. If one of them is a 3-digit number and the other is a 4-digit number, what is the smallest possible difference between the two numbers? Okay, so I know that the sum of the number is 3,160. I have one bigger number, one smaller number, right? So just compare them like that, small and big. Okay, two numbers. Am I right? So we are going to draw the comparison model. I'm going to compare them. So the small and the big, of course, the small number is smaller lah, shorter. The bigger number is bigger, longer. Total is 3,160. Now, if one of them is a 3-digit number and the big one is a 4-digit number. So the small number is a 3-digit number 1, 2, 3. The big number is a 4-digit number 1, 2, 3, 4. Okay. What is the smallest possible difference between the two of them? So which means I need to know the smallest possible difference. To get the smallest means I need to take away the biggest 3-digit number. I want to take away the biggest. So what is the biggest 3-digit number? What is the biggest number? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Which is the biggest number? 9 is the biggest number, right? So which means the biggest 3-digit number to find, you will put it as 999. Take away this. The 3-digit number is 999. Okay, so if it's 999, so what do I do to find the big number? I take 3,160. I minus away my small number. Okay, this is my total, sorry. 3,160 is my total. Take away my small number. You are going to get 2,161. Okay, now if I know that the big number is now 2,161, my small number is 999. Can I find the difference? Can, right? So the difference means minus. So I take 2,161 minus 999 equals to 1,162. This is the answer, 1,162. Okay. Ibrahim is thinking of two numbers. The only common factors, both of the numbers, or the only common factors of both numbers are 1 and 2. The first common multiple is 24. One of the numbers is 8. what is the number, other number? So I have two numbers. So I know that one of the number is 8. I want to find what is the other number. So the issue here is the common factor that they have is 1 and 2. The first common multiple is 24. Again, what are factors? What times what, right? What is a multiple means times table, in that times table. So since I have here that one of the number is 8, can we do times table 8 first? Can, right? Multiple of 8. So you can write out the multiples of 8, but before that, the first common multiple is 24. If you look at this, they say first common multiple, first common. So I don't look at times table 8 then. I just use 24, the times table of 24. Okay, 24, then 48, 72, and so on. The first one is this one. This is the first one. Okay, so we will actually assume that the next number, this one, to get the factor of the next number is 6 times 8. One of it is that, right? The factors, right? 6 times 8 give you 46. Okay, so one of the number, I'm just guessing that it might be 6 or 6 and 8. I'm guessing. Okay, so I know that 8 is one of it. So this is confirmed correct. So I'm guessing what give you 48 next? It is 6. Okay, so let's just check factors of 6. Now I'm finding the factors of 6. So it will be 1, 2, 3, 6. Now we check factors of 8. That will be 1, 2, 4, 8. Then they say the common factors for both of them is 1 and 2. Let's just check. For 6, I have 1, I have 2. For 8, I have 1, I have 2. See? So which means if the first number is 8, I have 8 already. What is the other number then? It is not 3, but 6. Okay? Miss Tan bought 36 keychains and 54 markers. She distributed them equally to her pupil in the class with no remainder. Very important, which means I can take 36 divided by the class pupils, then no remainder. 54 divided by the class pupils, no remainder. Okay? Each pupil received the same number, common. This is the keyword here. It means common. What was the maximum number of pupils in Miss Tan's class? So I know that I have 36 and 54. I can divide them equally. This means I'm looking at the factors. Common factors of 36 and 54. You see how I derive with the concept? Okay. Clues are given in the question. Just have to change them. Okay. So factors of 36 equals to, and factors of 54. I repeat, what are factors? Factors means what times what? Give me 36. Or what times what? Give me 54. Now, the factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, 36. Now you'll be wondering how I get all these numbers like this. 36 means 1 times 36, 2 times 18, 3 times 12, 4 times 9. Anyone else? No. So what did I do? I arranged them from the smallest to the biggest. 1, 2, 3, 4. Then I have 6. 6 times 6. Yeah. Then I have my 6, and then 9, 12, 18, 36. You see, it's in order of smallest to the biggest, right? It goes this way up. That's how you arrange your factors. Understand? Okay? So that's how I have this. Now, factors of 54 will be 1, 2, 3, 6, 9, 18, 27, and 54. If you don't understand how I get this, 54 is 1 times 54, 2 times 54, 27, 3 times 18, And then 4, you don't have. 6, you have. 6 times 9. Okay, that will be it. Then, you see, 1, 2, 3, 6, 9, 18, 27, 54. I go from here, go all the way up this way. Okay, that's how I arrange them. Now, between the factors I have here, I have the factors. Where is the common numbers? The common number is 1, 2, 3, 6, 18. Any more? No more, right? Now, they say maximum. So, which is the biggest common number? The biggest will be 18. So, how many pupils are there in her class? Not 9, but 18. Okay? 10 years ago, Megan was 4 times as old as Geeta. A comparison was made for 10 years ago, and Megan was 4 times. 4 times means 4 unit. This is Megan. Geeta is 1 unit. Their total age now is 45 years old. Means 10 years later. When I say 10 years ago, it means you need to take away 10 years because it's not now. Now age total is 45. 10 years ago means last time. In the past, what must I do? 45 years old minus 10 years ago equals to 45 minus 10 is 35. This is their age 10 years ago, which I'm going to use. I'm going to use this total, not the total now, because they are given the comparison here. The comparison that Megan was 4 times as old as Geeta is 10 years ago. So I need to use that. Okay, so now Megan and Geeta. Megan is 4 units, so you draw 4 units. And then Geeta is 1 unit, like this, okay? And their total is 35 years old. All right, so I want to know how old is Geeta 8 years ago. So you go and find out Geeta first in this model that is here. I want to find 1 unit. Now, how many unit is 35? 1, 2, 3, 4, 5. 5 unit is 35. 1 unit is 35 divided by 5 equals to 7 times table 5. Now, this is Geeta. This is Geeta 10 years ago. But what the question want is 8 years ago. Okay, so I want 8 years ago. So I must take my 7, right? My 7 years old. If I say 8 years ago means I need to add it with 2 years. Okay, with 2 years. Plus 2 years. Equals to 9 years old. So answer is 9 years old. Okay.